Hello and welcome to section 10.3. So here we're going to look at logarithmic functions. So we're going to use these over the next couple of sections in order to help us with solving exponential equations and applications with exponentials in it. So the kind of role of the logarithm is the inverse of the exponential function, and this helps us kind of use the log to get to the exponent. So in an exponential equation, the unknown is in the exponent. It's up there, it's hard to get to it, alright? So we're going to use the log to get to that exponent. Okay, so here's what the exponential function looks like. So the function f of x equals log, and then it has a little a at the bottom. You say log base a of x. So it's a logarithmic function with base a. The base is always positive. Whatever is in here always has to be positive, right? And a is not equal to 1. Okay, so that's kind of a special case that we're not going to look at, right? So basically the logarithmic function is equivalent to the exponential where the x's and y values are switched. Okay, so the log is the inverse of the exponential. So if we look at sort of this big picture here, if we have, this is what sort of we've been looking at. We've been looking at like exponential forms. Say x equals a to the y. A is the base, y is the exponent. Then its equivalent logarithmic form is this. Right? So these say the same thing. Right? But this is an exponential form, this is a logarithmic form. So you can see how they switch around is that the base a, is the base of the log. Right? The exponent goes by itself. That's basically what you're solving for. And this goes in after the log. Okay? So this conversion between exponentials and logs is very important because we're basically going to use this and some other properties to be able to evaluate and solve equations. Alright, so we're going to practice. So we're going to practice converting between exponential and logarithmic form. So let's put that there. I just ignore this. Okay. So part A says 2 to the 3 equals 8, which is totally true. That there's nothing to solve. But we want to convert to logarithmic form. So this is exponential form. Right, so basically, we can see what happens here. Right? If we mimic this, this is like the x, this is the a, and this is the y. So in the logarithmic form, the exponent goes by itself. So 3 equals log, L-O-G. The base stays the base. So base of 2. And then 8 goes after here. So 3 equals log base 2 of x. So when you're sort of writing a logarithmic form, you're solving for the exponent, right? So you're saying that it's basically the question you're asking is, how can I write this? Like 8 I can write as base 2 to the power to the exponent 3. So which exponent of that base of 2 do I need to write that number? Okay, so logarithmic form. Alright, let's look at part B. So we have 5 to the 1/2 equals square root of 5. Alright, so this is exponential form. Logarithmic form, we're solving for the exponent. So we're saying 1/2 equals log of base. This has base 5. We need base 5 here. of square root of 5. Alright, let's look at C. 1/2 to the 4 equals 1 over 16. Logarithmic form, we're solving for the exponent, so 4 equals log base 1/2 to the 1 over 16. Okay, so the base of the exponential becomes the base of the log. The base of the exponential becomes the base of the log. All right, that's it for those.